Dear students, welcome back to a new mathematics session. In today's session, we will begin exercise 6.3 from the chapter Applications of Derivatives. Let's move on to the topic. Let's begin with tangents and normals. Here the word tangent, it is quite familiar for us. We have learned these concepts in class 10. Tangent means it is a line that touches the curve at one point. Tangent is a line that touches a curve at exactly one point. For example, if you consider this curve and there is a point here, then the point which we have marked, we have taken as x1, y1. And if you draw a line that touches this curve at exactly this point, then that line is called the tangent. The property of the tangent means it is quite clear. The line, it will touch the curve at exactly one point. Then normal means usually it is a line which is perpendicular to a tangent to the curve. There is a tangent and that tangent it is passing through this point. If you draw a line which is perpendicular to that particular tangent, that means this is called the point of contact, and through the point of contact you have to draw a line which is perpendicular to the tangent. That is called the normal. So here the normal is this one. The concepts of tangent and normal, I hope it is clear for you. Tangent means if you consider a curve and if you draw a line that touches the curve at exactly one point, then that line is called the tangent and the point is called the point of contact. And if you draw a line which is perpendicular to that tangent through that point of contact, then that line is called the normal. Let's recall some of the basic concepts which we have learned in class 11. Equation of a straight line. So equation of a straight line, two formulas we have learned in class 11. That is, first one is point slope form. Means equation of a line passing through a given point and a given slope. Equation of a line passing through a given point. Given point here is x1, y1, and the slope usually we represented by using the letter m. So the equation is y minus y1 is equal to m into x minus x1. So here x1 and y1 are the given point and m is the slope. So since the point and the slope we are using, that's why it is called the point slope form. Y minus y1 is equal to m into x minus x1. When these two things are given to us, we have to use this formula. One more we have learned, that is passing through the origin. Equation of a straight line passing through the origin. Passing through the origin means here the point x1, y1 is 0, 0, 0. Because the origin coordinates are 0, 0. Means here y will be balanced, here only x is balanced. The remaining y1 and x1 will be 0. So the equation will be y is equal to mx. That is a formula. Y is equal to mx. So these two formulas you have to keep it in mind because we are going to use it throughout the exercise. Next is, there is a concept, two parallel lines will have equal slopes. When two lines are given to us parallel, from that statement we can conclude that their slopes are equal. If m1 and m2 are the slopes of two parallel lines, then we can say that m1 is equal to m2. Similarly, two perpendicular lines with slopes m1 and m2 are respectively, then perpendicular means you know that the angle between that lines will be 90 degree. So here m1 and m2 are the slopes, then we can say m1 into m2 is equal to minus 1, means the product of their slopes will be minus 1. From here, if one slope is given to us, if we want to find out the another slope m2 means quite simple, minus 1 divided by the given slope. Remember the formula, minus 1 divided by the given slope. We will be taking this m1 to the right side, so multiplication becomes division. Minus 1 divided by m1 will be coming. This formula also keep it in mind, we are going to use it. Slope of a line parallel to x-axis is 0. Next point is slope of a line parallel to x-axis. If a line is given to us parallel to x-axis, then if you are asked to take out the slope means you can write slope is 0 there. Then slope of a line parallel to y-axis is infinity. Then two curves intersect at right angles are called orthogonal curves. So here two curves are intersecting at right angles. How do we identify whether the two curves are intersecting at right angles or not? For example, there is two curves, it is mentioned here, drawn here, and just draw the tangents at this particular point. And if you draw the tangents, and if the tangents are intersecting at right angles at the point of contact, then we can say that the curves are orthogonal curves, because these two curves intersect at right angles. Then there are some key points we have to note. If 0 by 1 is given to us, it is 0. 1 by 0 means we know that it is infinity, and 1 by infinity is 0. So these are the main points which we need to keep it in mind for solving the next exercise. Next we shall discuss equation of tangents and normal to a curve. In this case, first we will discuss equation of tangents. Here, consider a curve y is equal to f of x, and I am taking a particular point on the curve, that is x0, y0. By keeping this as the point of contact, through this point I am just drawing a tangent. Here we are going to discuss how we will find out the equation of this tangent. Where we have drawn this tangent is we have drawn on the curve y is equal to f of x. And if you want to find out the equation of this tangent, we should know by using point slope form, means we should know the slope of this line. Of course, point is here, but if you know the slope, then we will be able to find out the equation of this tangent. Here, slope of the tangent of the curve y is equal to f of x at the point x0, y0 means slope of this line. Slope of this line, how do we get? Here, slope of this line we will be getting by differentiating f of x, means derivative of f of x. If you take at the point x0, y0, we will get the slope of the tangent. Here f of x, we know f of x is the curve, equation of the curve. And if you take the derivative of this curve at the point x0, y0, then that will be considered as the slope of this curve. Remember, if you want to find out the slope of the curve, we have to find out the derivative of y is equal to f of x, or the equation of the curve at the point x0, y0. Once you get the slope of the tangent, derivative of a function at a point gives us the slope of the tangent at that point. We have discussed this matter. Derivative of a function at a point. Here y is equal to f of x is the function. Derivative of this function at a point. Here our point is x0, y0. Gives us the slope of the tangent at that point. By using this concept only, we have written this one. Slope of the tangent we have got. Now once the slope of the tangent is there, means equation of the tangent, easily we can write y minus y0 is equal to f dash x0. F dash x0 means derivative of that particular point, derivative of that particular equation at the point x0, y0. Then into x minus x0. Here this is in the format y minus y1 is equal to m into x minus x1, point slope form. Here m we have taken as f dash, that means derivative of the function y is equal to f of x at the point x0, y0. That is what here it is mentioned, f dash x0 into x minus x0. So this is the equation of the tangent. Remember, instead of by hearting the formula, you should just keep it in mind the basic concept. Here the concept is point slope form. Y minus y1 is equal to m into x minus x1. This is the formula. And here we need a particular point. That point we have taken as point of contact, that is x0, y0. And here m is the slope of the tangent. Slope of the tangent we will be getting by taking the derivative of the given function at the point x0, y0. So this will be very easy concept, and you will be very familiar with it when you solve 2-3 questions. Let's begin the first question. Question number 1. Find the slope of the tangent to the curve y is equal to 3x power 4 minus 4x at x is equal to 4. Here slope of the tangent we have to find out, not the equation of the tangent. Here we are asked to find out the slope of the tangent. We know how to find out the slope of the tangent. Let's recall the concept. Slope of the tangent means we will find out the derivative of this function, and derivative at this point x is equal to 4. After finding the derivative, instead of x you put 4, then you will get the slope. That is what we have to find out. So y is equal to 3x power 4 minus 4x. As you know that slope of the tangent is equal to dy by dx, means we have to differentiate this one with respect to x. So that is, you can see here 3x power 4. 3x power 4 differentiation means x power n means n into x power n minus 1. I hope the formula is clear for you. Then 3 is a constant, just to keep aside, and n into x power n minus 1. Here n is 4. So 4 into x power n minus 1. N minus 1 is 4 minus 1. Minus 4 into x. Here 4 is a constant. Then derivative of x is 1. So 4 into 1 is 4. So if you don't know how to take the differentiation or how to take the derivative of this one, please learn it. Once again, 3x power 4 means 3 you have to keep aside, and x power 4 derivative is 4x cube. That is what it is written. So this one we are not going to write any step, just directly we will be able to write, so that you can save your time as well. So 4 is a constant, derivative of x is 1. So 4 into 1 is 1. Then 4 into 3 is 12, x power 4 minus 1 is 3. So this is the step I want to write directly. This step you can avoid. If you are quite familiar with the concept of derivation, means just directly you can do it. See here, 4 into 3, 12. We can write x power 4 derivatives 4x power 3. That 4 we are multiplying with the 3, we are getting 12. Then x power 3 is the balance. So directly we can write it. Then here 4 into x. 4 into x means 4 keep aside, derivative of x is 1. So 4 into 1 is 4. Likewise, directly we can write. You can avoid this step. Then derivative we have calculated, and at the point x is equal to 4, if you do it, then you will get the slope. So dy by dx at x is equal to 4 means here x you have to replace and put 4. So 12 into x replace with 4 means 12 into 4 cube minus 4. That is 12 into 4 cube, you will get 768 minus 4. That is 764. So this is the slope of the tangent at x is equal to 4. Move on to question number 2. The question is, find the slope of the tangent to the curve y is equal to x minus 1 divided by x minus 2, comma x not equal to 2 at x is equal to 10. We are asked to find out the slope of the tangent at x is equal to 10. As we know, slope of the tangent means first we have to find out the derivative, and after finding out the derivative, replace x with 10, you will get the answer. So always you should recall the process, okay, before start doing this, so that it will be familiar for you when these type of questions are asked. So here slope of the tangent we know, that is dy by dx, and this function is in the form u by v. So we know that u by v how to take the derivative. Denominator square we have to write. Then derivative of the numerator into the denominator minus derivative of the denominator into numerator. Once again, numerator derivative into denominator minus denominator derivative into numerator divided by denominator square. Then dy by dx means, first of all we will write the square of the denominator, that is x minus 2 the whole square. Then derivative of the numerator, our numerator is x minus 1, its derivative means dash you put, into the denominator is x minus 2, minus derivative of the denominator, that is x minus 2 dash into numerator. Now you can see x minus 1 derivative. X minus 1 means here derivative of x is 1, and here derivative of 1 is 0. That means we will be writing 1 here. So derivative of x only is there, so 1 into x minus 2 minus here x minus 2 derivative. X minus 2 derivative means here derivative of x only is there, this is 1, and the derivative of 2 is 0. So here throughout the bracket if you do, it is only 1. 1 minus 0, that is 1. 1 into x minus 1, denominator x minus 2 the whole square as it is. That is, when you remove the bracket, x minus 2 minus 1 into x is minus x, minus into minus plus into 1 is 1. Then plus x minus x we can cancel. Then after cancelling plus x and minus x, there will be minus 2 and plus 1. Minus 2 plus 1 is minus 1 divided by denominator is x minus 2 the whole square. Then dy by dx at x is equal to 10. We will get the slope if you do. That means replace this x value and put 10. That is equal to minus 1 divided by 10 minus 2 the whole square. 10 minus 2 the whole square means 8 square. Then that is minus 1 by 64. So the slope of the tangent at x is equal to 10 is minus 1 by 64. Move on to the third question. Find the slope of the tangent to curve y is equal to x cube minus x plus 1 at the point whose x coordinate is 2. So x value is given. X coordinate means x value. X is 2 here. As we know, the slope of the tangent means we have to take the derivative of the given function. So dy by dx means, that means d by dx of this one. It's quite simple. This step is not necessary actually. Just for understanding purpose, it is written directly. We can write the derivative from here. Derivative, just let's check how we write the derivative. This will be 3x square derivative. This will be 1. Here will be derivative 0. That is 3x square minus 1 plus 0. That is dy by dx at x is equal to 2. That is what the question. X coordinate is 2 here. Dy by dx at x is equal to 2 means replace this x and put it 2. 3 into 2 square minus 1. So 3 into 2 square. 2 square is 4. 4 into 3 is 12. 12 minus 1 is 11. So the slope of the tangent is 11. Move on to question number 4. Find the slope of the tangent to the curve y is equal to x cube minus 3x plus 2 at the point whose x coordinate is 3. This is just similar to the previous question. This will try it as homework. Next we shall discuss question number 5. Find the slope of the normal to the curve x is equal to a cos cube theta, y is equal to a sin cube theta at theta is equal to pi by 4. This is something different from the previous questions. Find the slope of the normal. Previously we have discussed how to find the slope of the tangent. Here slope of the normal it is asked. It is not a problem. If you know the slope of tangent, we will be able to find out the slope of the normal, because tangent and normals are perpendicular lines. Their product of the slopes will be minus 1. By using that relation we can find out slope of normal if you know the slope of the tangent. We know how to find out the slope of the tangent. That we will do it first. For that we need to find out dy by dx. But here again problem is there. Dy by dx directly we cannot calculate, because here x is separate given, y is separate given. X in terms of theta it is given, y also in terms of theta is given. So here first of all we have to find out dx by d theta. Dx by d theta we have to calculate, and here also dy by d theta is we need to calculate, because x also in terms of theta, y also in terms of theta. That is what we have to find out first. Then we have to find out dy by dx. So let's start. Here x is equal to a cos cube theta. X in terms of theta it is given. So when we differentiate with respect to theta, we will get a dx by d theta. Dx by d theta means d by d theta of cos theta, cos cube theta. Here as before, cos cube theta. Cos cube theta means this will be just in the form x power n. X power n means n into x power n minus 1. So 3 cos theta derivative, cos cube theta derivative if you take, you will be getting 3 cos square theta. Then again instead of x we are having cos theta. So cos theta derivative you have to write. Cos theta derivative is minus sin theta. That is the way we have to do. First of all, once again, a is a constant we keep aside, and cos cube theta derivatives 3 cos square theta using the formula n into x power n minus 1. 3 cos square theta. Then this cos theta derivative also you have to take. Cos theta derivative is minus sin theta. That is, when you arrange it, 3 into a, that is written, there is a minus n keep outside, then there is sin theta and there is cos square theta. It is written in order. Next is y. Y is equal to a sin cube theta. Here also differentiate with respect to theta. We will get dy by d theta. Same thing. A is a constant, keep aside. Sin cube theta, when you differentiate, 3 sin square theta will be coming by using the formula x power n. X power n is n power x minus n into x power n minus 1. So here sin cube theta means you will be getting 3 sin square theta into sin theta derivative. Sin theta derivative is cos theta. So that is what we have done. A into 3 sin square theta into cos theta. Just arrange it. 3a sin square theta cos theta will be coming. Just a rearrangement. Then dy by d theta is there. Dx by d theta is here. Dy by d theta is here. We want dy by dx. Simply divide these two. Dy by dx is equal to dy by d theta, because numerator we want dy. So this one first, dy by d theta by dx by d theta. Then dy by d theta, we have got here answer 3a sin square theta cos theta. Dx by d theta is minus 3a sin theta cos square theta. Then here just to do the cancellation means here there is 1 sin theta is gone, a is gone, 3 is gone. Then here cos theta and here on cos square 1 is gone. Then what we are getting is here numerator there is a sin theta, denominator there is a cos theta, and there is a minus sign. That is minus sin theta by cos theta, that is equal to minus tan theta. This is dy by dx. By using dy by dx, at x is equal to pi by 4, sorry, at theta is equal to pi by 4, we will be getting the slope of the tangent, not the slope of the normal. Anyway, let's find out that slope of the tangent. That is dy by dx at theta is equal to pi by 4. That is, when you replace theta and put pi by 4, minus tan pi by 4 will be coming. Tan pi by 4 is 1. There is a minus sign, so we'll be getting minus 1. So this minus 1 is our slope of the tangent. For writing the slope of the normal, we have an equation, slope of the tangent into slope of normal is minus 1. Previously we have discussed product of the slopes of two lines which are perpendicular is minus 1. Tangent and normal both are perpendicular. Slope of tangent into slope of normal is minus 1. Here slope of tangent we are having minus 1. So minus 1 you can bring to the right side. That means slope of the normal means we will be getting as minus 1 divided by slope of the tangent. Means this slope of tangent if you bring to the right side, it comes into the denominator. That is slope of the tangent we have now minus 1. That is minus 1 divided by minus 1, that is equal to 1. So the slope of the normal is 1. Move on to question number 6. The question is, find the slope of the normal to the curve x is equal to 1 minus a sin theta, y is equal to b cos square theta, at theta is equal to pi by 2. Same thing only, we are asked to find out the slope of the normal. And here x in terms of theta, y in terms of theta. Dy by dx we have to calculate. Same like the previous process. Dy by dx is the slope of the tangent. X is given 1 minus a sin theta. Here we have to differentiate with respect to theta. Means you will be getting dx by d theta. Dx by d theta is d by d theta of 1 minus a sin theta. So here derivative of 1 is 0. Then minus a is a constant, outside you have to keep. Sin theta derivative is cos theta. So we will be getting as minus a cos theta. Then y is equal to b cos square theta. Here differentiate with respect to theta. Means b is a constant, keep outside. Then cos square theta derivative is 2 cos theta. Then again cos theta derivative you have to take. Cos theta derivative is minus sin theta. That is 2b cos theta into minus sin theta. Here directly we should be able to write. Okay, b is a constant, keep outside. Cos square theta first derivative, that is 2 cos theta. That is what it is written, 2b cos theta. Then cos theta derivative again we have to take. Cos theta derivative is minus sin theta. Then when you arrange it, minus outside, 2b sin theta cos theta. Here dx by d theta is there, dy by d theta is there. Dy by dx we want. That means this quantity divided by this quantity. That is dy by d theta by dx by d theta. Then when you do the division, minus 2b sin theta cos theta, that is dy by d theta, divided by here minus a cos theta, that is dx by d theta. Then here also cancellation is there. Let's do the cancellation here. Minus minus is gone. Then there is cos theta is gone. Then the balance, there is 2b sin theta in the numerator, denominator there is a. Then dy by dx at x is equal to pi by 2. That is what the point is given. Then we will get the slope of the tangent. So dy by dx at theta is equal to pi by 2 is 2b by a sin, replace theta and put pi by 2. So sin pi by 2 value we know it is 1. So 2b by a into 1, that is equal to 2b by a. Then here slope of the normal, we know slope of the normal is minus 1 divided by slope of the tangent. How we have got this one? We know that previous question we have explained. Slope of the normal into slope of the tangent is minus 1. From there slope of the normal you can calculate minus 1 by slope of tangent. Slope of tangent we have got 2b by a, just substitute. minus 1 divided by 2b by a, that is equal to minus 1 into reciprocal of this one. 2b by a reciprocal is a by 2b. That is equal to minus a divided by 2b. So this is the slope of the normal. Move on to question number 7. Find the points at which the tangent to the curve y is equal to x cube minus 3x square minus 9x plus 7 is parallel to the x-axis. Question you have to go through very clearly. Find the points. Here we are asked to find out the points at which the tangent, means the point of contact we have to find out, at which the tangents to the curve. This is the curve y is equal to x cube minus 3x square minus 9x plus 7 is parallel to the x-axis. Okay, in which point that particular tangent on this curve will be parallel to x-axis. That is what we have to find out. Here we are asked to find out the points. First of all, tangents. A function is given to us, y is equal to x cube minus 3x square minus 9x plus 7. We will take and we will differentiate, because dy by dx we need. Here equation of the curve is this one. Differentiate with respect to x, dy by dx is equal to, this step is not necessary actually, directly we can do x cube. When you differentiate, it is 3x square, and here 3x square, when you differentiate, 3 into 2, 6x will be coming. Then 9x, when you differentiate, it will be coming 9. That is 3x square minus 6x minus 9 plus derivative of 7 is 0. Once again, derivative of x power n into x power n minus 1 means 3x power 2. That is what it is written. Here this 2 will be multiplied with 3. 3 into 2, 6. X power 1. That is x, 6x. Here 9 into derivative of x is 1. That is 9 plus 7. Derivative of 7 is 0. Constant. Then little bit of calculation we have to do. 3x square minus 6x minus 9. Here 3 is common. Let's take out 3 into x square minus 2x minus 3. 3 we have taken common from here. Then by splitting the middle term, we can factorize this one. That is 3 into, here the sum is minus 2 and the product is minus 3. So sum is minus 2. Sum is minus 2 means the numbers are minus 3 and 1. Minus 3 plus 1 is minus 2. And the product is minus 3. Minus 3 into 1 is minus 3. So the numbers are minus 3 and 1. So we are splitting this middle term as minus 3x plus x. That is 3 into, in these two terms there is x common. You have taken x, if you take out from x square, x balance. From 3x, x going out means 3 balance. In these two there is only one common, that is 1 into x minus 3. And in these two terms there is x minus 3 is common. You take out, that is 3 into x minus 3. If it is out, balance in this term there is x, in this term there is 1, so x plus 1. That is what here 3 into x plus 1 into x minus 3. This is the factorized form. We have got dy by dx. Now there is a given condition. Tangent to the curve is parallel to the x-axis. This is the condition. Tangent to the curve is parallel to x-axis. If a line is parallel to x-axis means the slope is 0. So slope of a line parallel to x-axis is 0. Slope of the line means dy by dx at that particular point will be 0. That means dy by dx will be 0. That means 3 into x plus 1 into x minus 3, that is equal to 0. And here the options are x plus 1 into x minus 3 is equal to 0. Then when we equate x plus 1 with 0, we'll be getting plus 1. When we go to the right side, it comes as minus 1. And x minus 3 equal to 0, if you take, x will be 3. So x is equal to minus 1 and x is equal to 3 are the chances here, are the solutions we can say. Then when x is equal to minus 1, y we can calculate from here. Y is x cube minus 3x square minus 9x plus 7. Let's put the value of x here. Minus 1 the whole cube, minus 3 into x is replaced with a minus 1. Here also x is replaced with a minus 1, then plus 7. Minus 1 the whole cube is minus 1. Then here minus 3 into minus 1 the whole square is 1. So minus 3 into 1 is minus 3. Then minus into minus plus, 9 into 1 is 9 plus 7. Then when you do the calculation here, we'll be getting the answer as 12. 9 plus 7. 9 plus 7 is 16. From 16 if you remove 4, we'll be getting 12. Then the points are minus 1, 12. Then here x is equal to 3 is another option. We can take x is equal to 3. When x is equal to 3, y is we will be getting when you put x is 3 in this equation. So 3 cube minus 3 into 3 square minus 9 into 3 plus 7. 3 cube is 27. Here also total 3 cube is there. 3 into 3 square. So 27. 9 into 3 27 plus 7. So 27 minus 27 is 0. Minus 27 plus 7 is minus 20. So the point is 3 comma minus 20. So these are the 2 points. Once again, just to go through the process, we are asked to find out the points in which point the equation of the tangent to the curve is parallel to x-axis. And first of all, we found the derivative, and since the line is parallel to x-axis means its slope is 0. Slope is 0 means dy by dx is 0. When we equate dy by dx with 0, we have got x is equal to minus 1 and x is equal to 3. By using these two values, we substituted in y is equal to given equation and given function. Then we have got two set of points, minus 1 comma 12 and 3 comma minus 20. So the tangent to the curve is parallel to the x-axis at minus 1 comma 12 and 3 comma minus 20. Dear students, today we have discussed question number 1 to 7 from exercise 6.3. Go through the solutions, and while practicing, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.